Okay. All right. Um, we'll get started with creating the NFT, the ICO dApp. I would have to restart the tutorial because we had some problems with the initial recording, and just so that everybody else can also view it, those who are not online, I'm gonna get restarted. Um, and I'm really sorry for the inconvenience. I know it's really strange. My internet is having issues. All right. Um, Good morning, everyone. Today we'll learn how to create the second part of the tutorial, which is to create the dApp for the ICO contract that we did last time. So open open up the ICO. I'm gonna delete this one so that I can start again. So open up the ICO folder under which you created the hard art tutorial last time. And yep, I'll paste the GitHub link. And I'm really sorry about what happened, but yeah, let's try to like create the next app again. So inside the ICO folder, um, sorry, inside the desktop. So just go to your ICO folder again, and inside that, create a next app, very similar to how you did in your NFT collection, and press enter for all these things. Okay, I guess my internet is pretty fast this time. Okay, nice. Cool. Now we gotta install in Web3 modal, which helps you to like connect with different wallets. We'll be using MetaMask and be using Web3 modal to connect with MetaMask essentially. And the last step is to go ahead and install ethers. This is very similar to NFT collection and whitelist, so I'm just hurrying this. Um, then we need to download this image. Do that. Open image in a new tab. Save image as 0. So just save it 0 under the public folder um, for your My app. So essentially, it should be inside this public folder. I think I missed. This should. This doesn't look right. Um, yeah, we don't need this. Okay. I think I by mistake installed Web3 modal inside my ICO folder. You need to do this inside the My app folder. Okay, don't make the same mistake. So just go ahead and install Web3 modal inside the My app folder, not in the ICO folder. That was my mistake. And the second one was installing ethers. So let's just go ahead and do that. That's the last step for completing this. Okay, all right. And for the CSS, you can just copy the CSS because we don't want to, like, you guys can change it according to whatever you want. We will just focus on, the essential parts of things like ethers and connecting with ethers. And CSS is something in which you can learn in your free time. So you can just copy the CSS. It's not a CSS tutorial, and I've seen like students create really, really beautiful CSS on their own. So go ahead and do it in your free time. I would really encourage that. It's always nice to improvise on things that you learn in the tutorial. So just paste the CSS inside your home.module.css file and don't worry about it. When you're free and have more time, you can improvise on the CSS. So that's not something that you have to learn. But I've seen like many, many students create such beautiful CSS. I sometimes I feel like I can't do that. They're so good at it. But it's practice makes you perfect. All right. So now we are on the fun stuff of things. We'll be actually creating the code. So let's get started. Yep. Okay. Now comes the coding part. So open up your file index.js. That's one of the files that when you create your my app is automatically generated for you. Zoom in. Okay, I hope you guys can see this. And okay, so some things they give you by default, but we don't wanna use most of the stuff that they give to us. So we'll be creating our own stuff. So let's just go ahead and delete most of the stuff they gave us by default and create our own things, right? Okay, so essentially you start by creating a div. You give it a title. So this is going to be the title for our website. And let's name it Crypto Devs ICO, I guess. And close the title. Then you have a meta tag, which is to add some metadata to your React app. So you just do metadata description, and content is essentially that it's an ICO app. Okay. So you gave this a meta tag. All right. This is again something we already did, so we can um, do this in fast forward. We don't have to repeat things. So this is just adding a favicon, nothing really special. You can add your own favicon if you wanna. Oh, sorry, not favicon, favicon, um, um, to your dApp. Okay, and all this should be wrapped inside a header. So metadata, title, and favicon should all come inside the header, which is essentially the head. And this comes from next head. This is again something that's inbuilt in the with the next library. Okay, um, I'm gonna keep the home.module.css next to it so that you guys understand what CSS I'm using. So start another div tag, and in this div tag we'll use the main container. So this is going to be our main container, and here is where we're gonna write all of our actual code, the main code. So that's why it's called style.main, and we'll give it all the CSS qualities. Um, Create another div, and this time we're gonna give it a header. So h1, and class name is going to be title. Yep. So let's give this a title, style dot title. Okay, and we'll say welcome to Crypto Devs ICO. So this is just to add an ICO, to add a header. Let me okay. Yep. So we added a header, h1 heading. Sorry, we added a heading, which was the h1 heading, and we gave it a style of title. So it's gonna have a font size of 2rem and margin of 2rem and then 0. And now let's just add some description, div class name, style, styles s. All this should be s. Sorry, styles dot description. This one, and yep, we're gonna describe what we're doing, right? So we're gonna let the users know what they can do. So they can claim, you can claim or mint crypto dev tokens here. So they can claim or mint crypto dev tokens, and this is the description that we are adding. All right, that's pretty cool. Now comes the essential part of connecting the wallet. So the user should be able to connect the wallet when they first, open the website. And for that, it's very similar to what we did last time. We'll be using use effect. So use effect gets called the first time when you open up the website or when the page gets rendered. And that's what we're going to be using so that the user's wallet automatically gets connected uh, when when they open up the website. And to check to check that if the user's wallet is connected or not, we'll keep track of it using a variable, and let's call it wallet connected. And this variable will keep track of whether the user's wallet is connected or not. So let's set this, and we'll use something called useState from React. So what does useState do? We talked about it in the last tutorial, but um, it returns a stateful value, which is wallet connected, and a function to update it. So this is the function which is used to update this variable, which is wallet connected. And essentially, the initial state of this variable is set to false. And that's what it does. So it's really helpful. React hook. It also gives you a function by default. So yeah, that's what we're going to use to keep track of things on whether the wallet is connected or not. Okay, so let's write some code in our use effect then. So if wallet is not connected, if it's not connected, we need to connect it, right? Okay, so we have to connect it using Web3 modal. Web3 modal is the library that we'll be using to connect with MetaMask essentially. So let's create an instance of Web3 modal, create a variable of Web3 modal, and keep track of the reference, keep track of the instance of that Web3 modal. So because we want to keep this, we need to persist it as long as the page is open. We need to persist this variable. We'll be using Web3 use ref. So let's create a reference, and I'll talk about what this is. Okay. So why are we using useRef here? So useRef creates a mutable reference object, and it persists, like you see it says, the returned object will persist for the full lifetime of the component. So the instance of the Web3 modal, if we create it using useRef, is going to remain for the full lifetime until the page is open, which is like until the user is viewing our website, which is really important, right? Like we want the user to remain connected for the whole duration of him opening the website. So that's why you need use ref, and yep, that's why we used it. And let's assign it to a Web3 instance. Okay, Web3 modal instance. Okay, so you say new Web3 modal. Um, we need to import Web3 modal first. Let's go ahead and import. So import Web3 modal from Web3 modal, and now we have this, um, and it's getting detected by VS Code, which is nice. And okay, let's pass some stuff here. So our network is going to be Rinkeby, because we want to connect to Rinkeby provider options. I don't think we need any provider app options, so we can keep it as empty, and disable injected provider false, because we want to inject, we want the injected provider, which is going to be MetaMask for us. Um, all these variables, how do I know about them is through reading the documentation that Web3 modal gives us. Um, yeah, so you can also read the documentation, and if there's any additional configuration what you want to do, you can read their documentation and create this. Okay, so this created, this is the constructor, there are some arguments, and let's just assign this to web3modal.current. So what is this current thing, right? This assigns it to the see, it says useref returns a mutable reference object whose dot current value is property is initialized to the past argument, right? So the dot current value is the current value of this web3 model instance, and that's what we have to assign it to, right? So we have to assign this new web3 modal to the dot current value, because even the initial value you pass here gets assigned to the dot current value. That's how useref works. And that's what we are doing, right? We are assigning it to the dot current property. Um, and yeah, so then after you assign it, it's gonna remain as long as the user is on the, it's gonna remain, this instance is gonna remain as long as the user is on the website, has the website open. Okay, so now that we have the instance and everything ready, we know we need to create a function to actually make the user get connected to the wallet. So let's call this function connect wallet. Okay, what is this doing? Okay, let's first create this function. So let's call this function connect wallet, and this is going to be an async function. Let's add a try catch to catch any error that we might have when the user is trying to connect. And we console that error so that we know that if there's an error, we can detect it. We're going to set the wallet connected to true, because after the user has connected their wallet, we should set the wallet connected variable to true. And we'll call this function here. So if the wallet is not connected, you first create a Web3 model reference, and then you call this wallet connect function. Okay. And another thing we want to do is we want to connect the user to, we need to connect it to a given network. We also need to check if the network that the user is connected to is a correct network, right? We don't want it to get connected to Ropsten or anything. So we will create a function which is going to return us, which is going to check that the user is actually connected to the correct network, and will also provide us with a provider and a signer in case we need it, right? To call functions on a contract. So let's go ahead and create this function. Um, so why I'm calling this function here is because before you set this variable to true, you need to check that the user is actually connected to the correct network. And I'll explain how we're doing this. So let's write some code here first, and then you guys will understand why we wrote it like this. So need signer is equal to false. Okay, try catch again to catch any errors. Actually, we don't need a try catch here because we are doing a try catch here. So yeah, we don't need it here. So constant provider. So provider is used to call any, you to get the um like the Yeah, so it's basically used to connect with the current provider, and provider is essentially used to call functions on the contract for any read value, right? So things that do not change in a contract. So you need a signer to sign transactions if you want to change the state in the contract, but providers are used to read the values and get the values which do not require a state change. Um, so you get the reference and you do current dot connect. Um, connect. And this is going to connect us to the current account that the user is logged into, right? Connect the current address to which the user is connected to. And I'm not sure if it tells you. Yeah, it doesn't show what it returns, but it essentially returns us a provider. Um, okay. That's from their documentation, so that's how you get the provider essentially from Web3 modal. Um, so from this provider, you can create a Web3 provider, and you're going to pass in. Oh no, this should be providers. Web3 mobile. All right. So what is this providers? Um, Web3 provider is a class inside this providers thing, and you see like how many wallets it's connecting to. So it's connecting to Wallet Connect, Portis, Fortmatic, all these providers, right? So you need it first determines what kind of provider that the user is connected to. In our case, it's going to be MetaMask, and then it passes it to the provider to this class that Web3 modal has, and it lets it know which kind of provider we want to use. There are many kinds of provider. So yeah, you need to explicitly tell it which kind of provider we want to do, and then it wraps it inside a Web3 provider class. Um, this class helps us get, this class has so many other functions that we can use to determine other things. So we can get the chain ID to which the user is connected using, because we've wrapped our provider inside this Web3 class. So you can call this function called as get network, and this is going to determine the network to which the user is connected to. Work should be small. And for us, we need the network to be ring B. So we're going to check if chain ID is 4. So 4 is essentially the chain ID for ring B. And if they are not connected to ring B, you just throw an error saying change the network to ring B. And you also throw an error saying um, change network to network. So it's essentially network to network. Okay. Um, I hope you guys can follow. If you have any questions, let me know. Um, I know like I'm going really fast. This happened because this wasn't supposed to happen, but obviously because of my internet issues, we have to rush this a little bit. But if you have any questions, let me know. But this is very similar to what we did last time, so I hope you don't have any questions. But just to repeat myself again, we first created a reference. So we created a reference of the Web3 modal so that we can call functions on the Web3 modal, and this reference is going to remain as long as the user is opened the website. Then we called the connect wallet, and this is only called when the wallet is not actually connected. So you call this function, and what it does is it calls another function which is called the get provider assigner. And what it does is like it takes in an argument called as need signer, which is like whether you need the provider or do you need the signer. And then what it does is like it connects it to the current address to which the user is connected to, and then it wraps it around a Web3 provider class. this Web3 provider class takes in the provider, the kind of provider you're trying to provide. So you can provide MetaMask. We actually looked at what kind of providers it can do, but um, like there are so many other providers you can use. But yeah, so you need to provide it what kind of provider it use. Then you wrap it inside a Web3 provider class. And inside that Web3 provider class, then you can call functions like get network, which, using this, you can determine the chain ID to which the user is connected. And in our case, we want them to be connected to Ring B, and the ID for Ring B is 4. So if they're not connected to Ring B, you throw them an error. Okay. And the last step is that if they need a signer, and why would they need a signer? They would need a signer if they want to provide to actually do a state change, or if the user is supposed to sign a transaction before sending a transaction. That's when you need the signer. If you just want to read something from the smart contract, you don't need a signer. So that's why we added another if condition, that if the user has said that I need a signer, you get the signer again from this Web3 provider class instance that we created. There's another function called as get signer. So you can get the signer and then you can return the signer. Otherwise, if they don't need the signer, you can just return the provider. So Web3 provider. It's very simple, very easy, and you see what's the use of Web3 modal, right? It provides you with this class, and it automatically does so many things for you. It tells you the network, it also returns you a signer, everything is wrapped and nicely done for you. That's why this library is so useful for doing things. All right. So now we wrote this function to get provider signer. We checked if the user is connected to the correct chain ID or not. We connected the user. So everything is done. And we set the wallet connected to true. Okay. Um, and we didn't pass anything here. And if you don't pass anything, by default, it means that it's false. This means we don't need the signer. We don't need a Web3 provider also in this case, but we called this because of this condition. We want to check that the user is actually connected to Ring B. So this was the main reason why we did that. We didn't want to like check any for any state or anything. We didn't want it to read any value from the contract, or we didn't want it to write to the contract, but we wanted to check if the user is connected to the correct network or not. That's why we called this function here. Um, okay, so now we are done with the connect wallet, and we can go ahead and do other things. So now that the user is actually connected, um, we can check. So let's create a conditional here. That's how you write conditional inside JSX. You have these curly braces and then a variable name. And so for example, in our case, we'll do a ternary, like, if is the wallet connected? If this is true, you render something, right? So you render something like a div. Um, yep, and you wrap it around these braces. Okay, and if the wallet is not connected, this is the other part of the ternary. You render something else. In our case, we'll return a button, and on click of this button, the user should be able to connect their wallet, right? So if their wallet is not connected, you call the wallet connected function, and yeah, so um, connect your wallet. Okay. So if wallet is connected, you render something else. Otherwise, you render a button so that they can actually connect the wallet. So that's what we're doing. Okay, so if the wallet is connected, now what we are supposed to do? We have to actually render some stuff which is important to the user. And let's do that. So inside the div, actually, let's just write it inside this. Okay. Um, we're gonna add some description again because we have to tell them some stuff that's happening. So just again create a div with some description, and in this description we'll show them the number of tokens that have been minted till now. I'm not sure if you can see it, but um, okay, I don't have that open, but we want to show the user how many CryptoDev tokens that have been minted till now, right? So when they first come to the website, they should be able to see that how many tokens have been minted till now. So let's just print that here. So say um, overall um, some number out of 10,000 have been minted. So what is this number going to be? We can keep track of this using a variable called as tokens minted. And this is going to be the total number of tokens that have been minted till now uh, in the world for our contract. So token minted, and then again set token mint. And initially we'll set this to 0, right? And this is going to be a big number because obviously if you remember from the contract that we created, the the variable that the contract is going to return is going to be of the form of a big number. So let's create a big number 0. So big number dot from 0, and we need to import big number. So we'll import big number from ethers. Let's import big number from ethers. Um, yep, okay, yep. So now VS Code knows what I'm doing. So I'm creating a big number from 0, and I'm setting this to the initial value of tokens minted to 0, which is a big number because our contract returns a big number. So we need to keep track of that um, using this. Okay, awesome. Um, we don't have any questions. Okay, so the next part of the thing that we have to do after creating this variable is to um, show it to the user here, right? So let's do that. But we don't want them to see a big number, right? We want them to see a number. We don't want them to see, like, they don't, most of the users don't understand what a big number is. I know, like, most of the developers do who are like coding in the blockchain ecosystem, but a normal human who's not a developer doesn't know what a big number is. So we need to format this. So what this format ether function does is it takes a big number. So it takes a big number and it converts into a string. So that's what we want, right? We want to take a big number and convert it to string. And that's why we're using this. And this is offered to us from the utils class from ethers. Um, and yep, that's what we used here. Okay. We also need to show them how many tokens they have minted till now. So this is like the overall that have been minted, but we also need to show them how many they have minted, right? So let's create another div. Um, and inside this div, again, class name is going to be styles.description because we are adding some description here. And we're going to say you have minted um, some number of CryptoDev tokens. And to keep track of that, we will have to create another variable, and let's name that variable balance of CryptoDev tokens. So this variable will keep track of the number of tokens that the current address to which the user is connected to can have, right? How many tokens does this address have? And you also need to have, it's a big name, so I'm just going to copy paste it here. Okay, set balance of cryptographic tokens. And again, this is also going to be set to 0 because this is also going to be a big number. So balance of cryptographic tokens, set balance of cryptographic tokens, and use state 0. All right. And again, very similar to how we did it here. You use the utils function and you convert this big number into a string and display it to the user. Okay, I'm having some issues here. So this div, okay, this should be a closing bracket. Okay, awesome. Nice. So now we can display how many they have minted till now and also how many have been minted in general. That's pretty cool, right? Okay, now let's create some functions so that they can actually mint some tokens. Till now we were just doing, showing them stuff, but now they should be able to mint, right? Like, and that's what we're going to be using coding now. So let's create a function called as render button. It's a general function which is going to return a button given the state of the user. All right. Um, let's do that. I'm just checking if we have any function questions. Give me 1 second. No, okay. All right. One person is asking, how did you do so good at ICO dApp? It's practice. When you keep doing multiple, you keep doing the same thing multiple times, you become good at it. Also, yeah, like we all make mistakes, and even if you make mistakes, it's fine. But yeah, I feel like the more you practice, the more you'll understand how to do things, and there's going to be a pattern that's going to get developed inside your mind, and that's the most important part of programming. Pattern detection plays a very important role. Okay, let's go ahead and create a mint function. Re- um, so from this function, we have to return two functions. So if you remember, there were essentially um, two things you could do. You could like mint tokens and you can also claim tokens. So we have to return the user a mint function or a claim function based on if they can actually claim if they have any tokens to be claimed or not. So first, let's write um, a simple like mint function. Mint, yeah, a way for the user to be able to mint. So let's create a div, and we're going to style it as display flex. If you guys know what flex is, you should understand why I'm doing this. But essentially, it's a CSS property where you can assign where whatever that gets rendered is in the form of a column. So this is how you like put your stuff in the website. So essentially, if you want to display um, two things in a row in a column format. So like, you know, um, so like, for example, this thing is a row, right? So this is column 0, this is column 1, column 2. So that's when you say that I want to display things um, as flex column, right? So they should come in different columns. That's what flex column means, like something very similar to this. So you basically create different columns for any div that's inside this div. So any div you add here is going to get converted to a separate column of its own, something very similar to here, right? So this is one column, this is one column, this is one column. So that's what we're doing. That's what we're doing. And yep, so we create column number 0, and inside the column number 0, we'll have two things. One is going to be an input, and what is this input going to do? Is going to be the input that we take from the user to determine how many tokens they want to mint. So type is going to be number, and placeholder is going to be um, amount of tokens they want to mint, and um, there has to be an on-change function that gets that gets called whenever someone changes the value in the input field. And let's keep track of this input, right? We need to keep track of how many tokens the user wants to mint. So let's call this token amount. So go ahead and create another variable called as token amount. This is the amount of tokens that the user wants to mint. And set token amount, and we again set this to 0 as a big number. And yep, now we can keep track of the number of tokens that the user wants to mint. That's good. So yeah, so E is like whenever there is a change event, or whenever this gets called whenever the user is changing the values inside the input field, and you set the token amount now, and you convert this into a big number. So you convert e.target.value into a big number, because that's what our contract needs. It needs a big number. So you take e.target.value returns the value that the user has entered in the input field. So you take the value that the user has entered, you convert it into a big number, and then you set it to the token amount that the user wants to mint. And to actually mint it, you need a button. And for the button, you just say class name is equal to styles dot button. This is in our CSS that we created, and it's going to be disabled based on if the token amount is 0 or not. So if token amount is 0, this button should be disabled, right? Because the user hasn't entered any amount that needs to be minted. You say mint tokens here, and what else do? We need to call the mint function. So now we need to create a mint function, and we need to call it. So on click, so when someone clicks this button, they should be able to mint. So let's do that. Okay, and mint, let's name this mint crypto dev token, and pass in the token amount. Token amount is going to be the amount of tokens they want to mint, and we're going to create this function called as mint crypto dev tokens, so that the user can actually mint it. So let's create this. So const mint crypto dev token async, and this is going to take in an amount. This is the amount that the user entered, and let's add a try catch to catch any error. Console.error. Yep, and okay, so now because we want to mint, we want the user to sign the transaction, um, because we want to know the address of the user who wants to mint it. And for the user, for us to mint the tokens to their account, we need the user to sign the transaction so that we know it's them and it is authorized by them. And that's why you need a signer. So you use this function that we created last time, and you pass true because this time we need a signer. We are going to change the state of the contract. Okay. And we're going to get an instance of our token contract, which is the crypto dev token contract that we created in the last tutorial. And we need the address, we need the ABI, and we need the signer. Okay, so let's go ahead and add the address and yeah, let's go ahead and add the address and everything else. So inside the Maya folder, create a new folder called as constants, and this is going to keep track of all our constants. And inside the constants folder, create a file called as index.js, and this is essentially going to, keep track of all our constants. So what all do we need? We need the token contract ABI. Um, okay. We need the token contract address. Um, okay. And we need the NFT contract as well, because we need to call that to keep track of, I talked about that for each NFT, the user is able to claim 10 tokens. So that's why we need it. We need to call the NFT contract address and determine how many NFTs the user has and how many tokens they can actually claim. And then you need the NFT contract ABI, because you need to call some functions using the ABI. Okay, so to get the ABI, you can go to artifacts, contracts, and cryptodev and here, and from your, and you can copy the ABI. So here, and keep going till this thing, and you copy this. This is going to be like an array, and you paste it here. Okay, so this is my ABI. For the NFT contract address, I have this NFT collection that I deployed. You have to use your own address and use your own ABI. But for me, I already have it. You can also get it from your NFT collection constants file. If you have it on your GitHub, I have it on my GitHub, so I'm just copying it from here. It's a big ABI. Okay, so this is the NFT contract. Oh no, that was supposed to be the address. NFT contract address and NFT contract API. Okay, so I pasted the API, and now we need to paste in the address. I also have the address with me, so I'll paste the address. And for the token contract, I also have the token contract address because I've already deployed it. So, but yeah, you have to use your address. Don't copy it from here because that's not going to work. You need to use your own, otherwise, nothing is going to work. Everything is associated with your address, so make sure you do this. My thing is not going to work for you. I mean, yeah, don't copy. This is for your learning experience, so make sure you use your own address. So, all right, I minimized this, but now I have my ABI for the NFT contract, NFT contract address. I have the token contract ABI, and I have the token contract address. So I can go back and provide this contract instance and the address, the contract instance, which contract interface. Interface is nothing but the ABI, and then the signer, right? So let's do that. So token contract address, then token contract ABI, and the last thing we need is the signer. Boom. So now we have an instance of our token contract, which is really cool because now we can call functions on this. All right, that's pretty cool. Now we need to specify the value that we have to send along with the amount. So this is going to be the value that we have to pay for being able to mint this much amount of our tokens. Remember that the price of one crypto dev token was specified to be 0.001, and that's why you need to pay 0.001 times the amount to mint this much amount of tokens. And this is the price of one token. So that's what we're doing. And then you just create a transaction. So token contract dot mint, we call the mint function. We specify the amount of tokens we want to mint, and we pass in the value. So value, you have to pass it inside these parentheses because um, that's how you do it in ethers. The value has to be, value is the second argument it takes in. Um, it's like an optional, it's like the optional values. So utils, then again, you need to convert this value into big number. Actually, isn't this already in? Okay, JavaScript is recognizing this as a number, but we don't want a big number. We don't want a number, we want a big number. So that's why we first need to convert it into a string because JavaScript is recognizing this as a number. This was, so the amount we passed was a big number, but JavaScript is recognizing this as a number. So that's why we need to convert this into string, and then you need to parse it into a big number. Because parse ether takes in a string, it doesn't take in a number. So that's why you need to convert it into a string, and then it's going to return the big number for you. This is one of the big disadvantages of using JavaScript, because in TypeScript you could have like possibly told JavaScript that, you know, to, explicitly specified that this is a big number, don't convert it to a number. But yeah, you can't do that in JavaScript, and that is one of the biggest, disadvantages. You can't specify the type that you want. Um, okay. Um, Now we need to wait for this transaction. And while we are waiting for this transaction, we have to show to the user that we are in the loading phase. So let's create another variable called as const um, loading and set loading, um, so that user knows that we are in the loading phase, and initially set it to false because initially the user is not loading anything. Okay, so use loading false. And okay, while we're waiting for the transaction, we have to set the loading to true. That makes that hopefully that makes sense because like you need to set loading to true for them to wait, and then you wait for the transaction to get mined. So you wait for the transaction to get mined, and then after it's mined, you can set loading to false again because now we're not loading anything. And you can alert the user that, hey, you successfully minted some tokens. So you just say successfully minted crypto dev tokens. Okay. So we're gonna alert the user that you're done and you've minted. So after you've minted, you need to like update the amount of tokens that the user has. If you remember, we were keeping track of the balance of the tokens that user has and the amount of tokens that have been minted overall. So we need to update, these variables. You can't just keep it to 0. So let's create some functions to get the new balance and to get the new balance of the overall total supply and to get the new balance of the user. So let's create get balance of um, crypto dev tokens. This is going to get the new balance the user has. We are also going to get the total token balance. This is the total balance that total token minted. This is the total tokens that have been minted in the world. And we can also get, the total tokens that have been. Actually, first, let's just do this. Get balance of crypto dev tokens and total tokens minted so that we can get the um, updated values of the balance of the user. So cons get balance of sorry get balance of crypto dev tokens. This is going to be an async function, and let's add let's try to understand add a try catch. Um, Error console dot error to print the error. Okay, and try. So because now we're just gonna read the value from the contract because we just wanna read the value of the um, balance of the crypto dev tokens that user has, we can just get the provider and we don't need the signer. So I'm not gonna pass anything, and by default it's going to assume that we don't need any signers, so it's good. Then you can copy this token instance, a token contract instance, and we need the balance. So you do the balance and await token contract dot balance of. So if you remember what balance of is, balance of is this thing. It is used to get the balance of. It takes in the address of the owner and it returns the number of tokens that the user has, but it needs the address. So we need to get the address somehow, and to get the address, we need to use the signer because only a signer is associated with an address. So you get an instance of the signer, um, and then from the signer, you can get the address. Uh, and then we'll pass this address to the balance of function because it needs the address of the owner. Okay, so now we need have the balance, and you can set the balance of crypto tokens to this balance. Pretty easy, right? Nothing too fancy. Oh, actually, we need to set this to provider and not signer because we just want to read from the token contract. Okay. If you have any questions, let me know. Um, how much time you doing Web3 stuff? Asking because I mean, how much time we can come up to your level? Um, I mean, I've been doing it for many years now, but the thing is, like, when I started, there wasn't any good resources. When I was starting, I didn't have all this that you guys have. So it took me a lot of time to reach here because most of the things we had was just documentation. There wasn't any good tutorials back then. We didn't even used to use Ethers.js. Everything was like Web3.js, which really didn't have any good documentation. Um, so it was not very similar. So the time it took me cannot be compared to how much time it's going to take for you because now you guys have like so many resources available to you. These things that we are teaching you, it took us many years to learn. But that's what LearnWeb3 DAO is. It teaches you things in a very structured manner, something that I didn't have when I started. So if you complete the levels and you understand what's going on, I'm pretty sure you'll be very confident in, you'll be, if not very confident, you'll be confident enough to, create your own side projects. And the more and more you practice, you can easily be better. within a year, or you know, but you have to put a lot of consistency and a lot of effort and really try to understand what's going on. Just copy and pasting code is not going to help you. Even if you're like, banging your head and you feel like I should just copy the code, you should not do it. You should always ask for help, because the moment you copy the code, you're not understanding what's happening, and that's not good. Then, if you don't understand things, it's going to take you more than um, even where I am, or maybe more years than what I'm doing. So it's more up to how much you go into depth and understand the why behind the things, and not just copy paste code, and not just follow tutorials. That's why we have these live streams, so that students can understand the reason behind why we wrote this code. Because uh, in our tutorials, we just tell you, we even though we provide you with comments, and we provide you with things that you can read and understand, you don't understand the flow of things, and that's why these live sessions help, and you can ask questions. But yeah, my suggestion is that um, um, it's going to take you time based on how much you understand the why. I feel like most of the resources we give you at LearnWeb3 DAO should be good enough for you to get, you know, a good understanding of what's going on in the space, and we make you familiarize with almost all the technologies that exist, which are important for you to get started. Obviously, you have to like learn other technologies that are coming up, but knowing the fundamentals knowing the fundamentals well strengthens you to learn other things, strengthens you to learn other, blockchains, and everything. Once you understand what's going on with ETH, it's very easy to understand why Polygon is needed, or why, Arbitrum is needed, or why Optimism is needed. These things are very interconnected. And if you understand the why behind why ETH functions this way, you'll understand the importance of Arbitrum, or Optimism, or Near protocol, or like, other protocols that exist. But if you don't understand one thing, and you're just like going around and messing up with your fundamentals, you won't understand, and then it's going to take you a hell lot of time, because you'll be confused. And that's what I see like beginners do. They get confused with so many chains that they don't focus on one thing. Once you focused on one thing, you can easily understand what's going on with the rest of the things. um, and that's what I did. I focused on one thing. I focused on ETH, and I focused on the ecosystem, and I tried to understand what's going on without, um, going ahead and doing other things. So yeah, the time is more dependent on you and your effort. You can probably do it faster than what I did. Why we need to call the function at every function call? Provider, to put the provider in the state. Um, So why are we calling it here is essentially like, obviously this code is not optimized. We haven't written the most optimized Web2 code. Um, you can do that, right? But we want to teach you. So that's why we are writing repetitive code, the code which is like, which every step you're declaring a provider, you're declaring a contract, so that you get a hang of how to do these things. Obviously, you can optimize this by a large amount. You don't even need to like, create a new contract instance every single time. But we intentionally do this because we want you to practice. These tutorials are for practice, not for like optimizing the code. This is for you to practice, writing these understanding why we required a signer here and why we required a provider here, and practicing declaring these things, practicing what going goes inside this thing. That's why we wrote it like this. That's why we ask you to continuously do this, create a new instance, declare it, so that the more you type, the more you understand, and the more you remember things. Obviously, you can optimize this to any level possible, right? Um, you can optimize and do so many things much better than how we did it here. But this is not meant for optimization. This is more um, um, you know more focused on the um, yeah, it's more focused on learning. um, okay, the next question is, should be divided into smaller boxes instead of having the listed text in the code. Yeah, that was something we were thinking of. Um, I think initially we just went forward with one way, and then we didn't want to um, change the pattern. So that's why we didn't do it. But maybe in the near future, like after we are done with senior, we can split the code templates and understand, make the students understand a bit more. But yeah, initially we didn't think of it, and we created our tutorials in one kind of a pattern. But maybe in the future, yes, after we release senior and after we have a little bit more time, we can split the tutorials a little further. But I really hope that these videos help you, because I go here explaining each segment of the code separately. So yeah, I understand that's something we can definitely do, and I didn't think of it before, but now that is something that is coming up, and maybe definitely we can do that in the near future. There are many things that we are still doing, like people are requesting, like for example, not having separate repos for every level. But these were things that we didn't think of before. But these are, improvements we have to do, and for sure, like in the near future, we can do that. Okay, let's continue. So the next function we have to do is, so first we did the get balance of tokens. The next one is get total number of tokens to be minted, get tokens to be claimed. So, sorry, to be tokens minted. Um, So it's going to be very similar to what we did with our balance. So let's do that. So get tokens minted, async, um, and then try catch, console dot error. Okay. And again, we just need a provider because we just want to read a value. So we just get the provider or signer. We create a token contract. So token contract, um, and um, you do give it the address, you give it the ABI, and you give it the provider, right? And to get the total number of tokens that have been minted, tokens minted is going to be await token contract dot total supply. So total supply is a function which you can call to get the total number of tokens that exist in the total supply. And then you can set this variable. Cool. So now we have this ready, and now uh, this is going to, automatically render the new stuff for us. Um, okay, that's pretty good improvement. We are almost done with most of our code. I think one of the other functions that we have to write is to be able to claim. So the user should be able to claim the tokens based on the number of um, NFTs they have. So let's do some stuff here for that. Okay, so go back to your render button thing, and let's add some buttons here. So if you are in the loading state, not here, outside the return. So if you're in the loading state, then you have to return a loading button that I am that we are waiting for the transaction to get mined. So button class name styles dot button and loading dot 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 and then button. Okay, so this is one of the functions. Then we also need to create um, keep track of tokens claim to be claimed. So this is the number of tokens that the user can claim. So let's do that. Um, to be claimed. Okay. So let's create this variable tokens to be claimed, and this is going to keep track of the number of tokens that the user can claim. And then we can create a function which can retrieve the number of tokens that need to be claimed. So let's do that. Tokens and that tokens to be claimed, and use state. Again, this is a big number um, because this is something that's going to be returned back from the contract. So yep. So create a function called as const get tokens to be claimed. So that we know how many tokens the user can actually claim. Okay, and do this, try catch and try. So this again needs a provider because we're just reading from the contract. Okay, and this time we need to call the NFT contract. And why do we need to call the NFT contract? Because we need to determine how many tokens are to be the user can claim based on um, the number of NFTs he has. So NFT contract address, NFT contract ABI, and then the provider. Okay, let's do that. And okay, now let because we are going to get the balance of the NFTs that the user has, because only based on the NFTs we know how many tokens we have to give them, right? So we again call the balance of function, and we need the address. So you call the signer um, um, and from the signer you get the address. See, the advantage of repetition is that you understand things now, like why, how we get the address, how we do everything. It's really helpful, and the pattern just keeps, um, it keeps developing inside your brain. So if the balance is zero, this means that if the user doesn't have any NFTs, so tokens to be claimed should be set to zero, right? Because they don't have any NFTs. Else, if which means that they do have some NFTs, what are we gonna do? Okay, so we're gonna initially we have to run the loop for the number of NFTs they have, and then we have to set um, the number of amount that of tokens to be claimed. Let's write some code, and after writing some code, we'll understand what's going on. Next address, I, and cons claimed. Mhm, mhm. Um, Claimed and token ID, and if not claimed, you increase the amount. And after this loop, you set the tokens claimed to be big number dot from amount. Okay, so if you remember, we had another function called as token of owner by index. So what you have to do is that you have to loop through the balance, that is the number of um, the balance of NFTs that the user has, and for each balance, like because the if you remember the token of owner by index, what it does is it takes the address and it takes the index, right? So you pass in the index of the array, you pass the address of the owner, and it returns you the token ID at that given index of the at that given index. And you have to check if the tokens have been claimed for this token ID. And if they have not been claimed, then you increase the amount. Otherwise, you don't increase the amount. So let's look at what's happening here. So if you remember, we did something very similar here. So we checked if the user, token of owner by index, that if the user has already claimed a token ID, you don't increase the amount, but only if they have not claimed it, you increase the amount and you set the token ID claimed by for to be true. So only for the token IDs that have not been claimed, you have to allow the user to be able to um, claim the token. So it's exactly similar, but we are doing it on front end this time, so that you don't have to call the contract and so execute so many things before you actually determine that there are no tokens that the user can claim. So instead of calling the smart contract and paying gas, we computed this on front end so that, because we don't have to pay gas here, we can already determine how many tokens that user can actually mint. Um, all right. Um, so that's going to set the tokens to be claimed. Um, and this function is really important, right? And if there is an error, you set the tokens to be claimed to be 0, obviously, right? Okay, so that's pretty cool. And let's go ahead and also call this function after mint, like to get the most updated value. um, it's always good to keep track of the most updated value, so after every function call we can get the most updated value for all these things. But okay, so tokens to be claimed, we created a function to get the tokens to be claimed, and now we have to, be able to render this, be able to show to the user how many tokens they can actually claim. So let's do that. So create a div, and inside the div, um, you need to create a class name and styles dot description, and then you say tokens to be claimed. This is the amount of tokens that are to be claimed into 10, because um, you need to give them 10 tokens per NFT. So these are the number of NFTs that for which the tokens have to be claimed, and you multiply by 10 because you give for each NFT you give 10 tokens, right? And then you say these many tokens can be claimed, and then we need a button to actually claim it, right? Pretty simple. Um, so you do class name, you do styles dot button. It's pretty easy once you keep doing it. You understand very easily what's going on. And let's go ahead and claim tokens. On click, we need to create a claim crypto dev tokens. And this is going to be the function to be able to, be able to call it. So let's go ahead and create this function. So const claim crypto dev tokens. This is going to be an async function. Okay. Let's try catch as usual. Okay. And now you already know what we are supposed to do. So signer, get provider or signer, set it to true, create a token contract address instance. So to call the contract, so you go here, token contract address, token contract ABI, and signer, and you create a transaction, and you wait to you call the claim function. You set loading to true. Obviously, you wait for the transaction to be mined, um, and you set loading to false, and then you alert that successfully claimed crypto dev tokens. And obviously, you get the updated balance and everything. So you just call these functions again, and yeah, this should be it. I think we should also call this function initially, just to get the initial balances as well. So in our use effect, where is our use effect? Where did it go? Okay, yeah, here. So after Connect Wallet, you can get all these updated balances first when the page renders, and also we can make this use effect, um, you know, to be rendered again every single time there's a change in the wallet connected button value. Um, it can act as a dependency. Okay, I think we are done here with most of the code. Um, we can add some stuff here. So right now we just did this and we added a main container here. Let's add a footer. So just to make it pretty. So footer, class name, styles.footer. We're done with the logic. It's just, you know, made with, um, so heart is, I think, 10084. Okay. By cryptographics. Okay. Made with love. So this is the ASCII for the heart thing. And let's create another div to show the image. You remember the image we downloaded? Let's show this just to make it pretty. We all like pretty things. So let's do that. Um, not style, not image. And src, if you remember, is going to be 0.svg. Dot slash. So for accessing anything inside the public folder, you can just do dot slash, and um, yeah, it automatically figures it out that it's from the public folder. Awesome. Okay, so we are almost done with all the code. Let me npm run dev this. So just do npm run dev. Um, I'm going to open a Chrome window. Um, okay, we isn't allowed in a non-async function. Okay, where is the error coming from? Let's see. Okay, line number 206. Okay, let's go ahead and see what's happening here. Okay, yeah, no, we can't add in a wait here. This is not an async function. So I'm gonna restart this because it's a little bit messed up now. So let me close this, localhost 3000. Let's see if it works. Okay, nice. Okay, I need to shift to link B. Okay, let me bring this full screen so that all of us can see what's happening. Okay, am I connected? Okay. Is it showing here? Web3 providers dot is not a constructor. Okay, let me see what's happening here in my code. Okay, let's see. So it says providers dot providers dot web3 provider is not a constructor. Hmm. Where I think it was in the get provider assigner function. Okay, so it's saying that it's not a constructor. Okay. Mhm. Hmm. I think. Oh, I think we're supposed to use the providers from ethers. Maybe that's why. Let me check. That's the case. Oh yeah, that's why it wasn't working for me. Yeah. So we are supposed to use the providers from ethers. VS Code imported the wrong provider. We don't need to use the provider Web3 provider class from Web3 modal, but actually from ethers. And then you see like, yeah, that's why I was getting confused. Like, why is it not opening anything? Okay, so yeah, this is the Web3 provider class we are supposed to use. And now you see like it takes in the provider, and yeah, this is the class that it has the network, it has everything, and um, it has many other functions that we were supposed to use. I used the wrong providers thing. So yeah, this one I think is what we were supposed to use. Yeah, and now I can open it up. Last time I wasn't able to even click on this. What was happening? Okay, okay. Now there's another error. Token address is not defined. Okay. Token contract address. Um. Oh yeah. We forgot to import these things: token contract ABI, token contract address, NFT contract ABI, and NFT contract address from Constance. Yes, obviously we need to import this, and boom. Okay. Um, cannot read properties of undefined reading map. Mhm. Oh, where is this thing coming? Okay, let me check. Mhm. Get tokens to be claimed. New contract. New interface map. Mm, mm. It's not able to read a value. Okay. Why is it not able to read the value? Um, let me check what's going on. Oh, yeah, obviously. We didn't export it. Silly mistakes you make. Export. Obviously, you need to export it, or else how would it know? Okay, okay. Now another problem. Get address is not a function. Signer dot get address is not a function. Signer dot get address. Let's see, where do we have it? Get address this not a function? Hmm. It's also saying token contract is not defined. Where is token contract not defined? Oh, here. Okay. Yeah, we forgot to define the token contract here. So yeah, you need to define the token contract. So token contract address, token contract ABI, and we need the provider. Okay. Yep. Obviously. All right. Okay. Seems like the other also went away. Oh no. Actually no. Signer.get address is not a function. Why is not? Why is this not a function? That's very strange. Okay, let's see where we're doing this. So one place is this. Okay, and other place is this. Is okay. Let me first comment it out and see if this is the place where this is happening. No, not this one. The other one. Okay. Hmm. So because of this, balance is not defined. Okay, yeah. So the problem is here. Hmm. Why is it not allowing this? Get provider signer. Get addresses. Set it to true. Let me check what's happening here. The web3 provider dot get signer. You return the signer. Okay. This looks right. Did we mess up any imports again? Let me check the imports again once. Okay. So from ethers, you do the providers, your utils, contract, and big number. Okay. From web3 modal, you do this. From constants, you do this. Um, looks right. Hmm. It's very strange why this is happening. This is not a function. Okay, sign. Mm, okay, let me add a console.log here to check if it actually goes in this. Log getting the signer. Sorry for this. I don't really know why this is happening. Let's see if it's doing anything. Okay, it gets the signer. But oh, did we? Oh, yes, obviously. We forgot to await. Yep, that was the problem. Okay, yes. Okay, yeah, obviously. Getting the sign. I can delete this now. All right. Um, Zero tokens can be claimed, and it still shows me a claimed for tokens thing. Okay, so that's a bug. We should not be able to see this if um, tokens claim. So you have to say is greater than um, some value. So let's see. Um, right now it's still showing me the claims token button, even though that's not what we want. Mm, tokens to be claimed. I guess if you can just set it to greater than zero. Okay. All right. Oh, okay. Nice. So this is something that I've already created, and I don't have any tokens that I can mint. So that's one of the reasons why it doesn't show me anything. Um, the formatting here is little off. So you have minted. Uh, where is the you have minted? Okay, is it okay? Nice. And where is the mint tokens? Hmm. I guess that's fine. So let's just mint 20 tokens and see if it works. So like you see that it's already connected. I don't have any tokens that I can mint, that I can claim, sorry. And so that's why I can just mint my tokens here. And it's gonna go ahead and you see that it calls the mint function. It sets everything. You can confirm the transaction and yep, let's wait for the transaction to be minted and then it should update this value. Okay, see, so you have successfully minted crypto token and boom, it updated the values. My crypto tokens increased and that's how it's done. Nice. Sorry for all the bugs. Live stream always has some bugs that you can see, and I'm pretty sure it works with the claim thing as well. You guys might have some claim left. I think I already claimed everything, so that's why it doesn't show it for me. But I was able to mint it successfully, so that's pretty good. Um, yeah, so we're done with the stream. If you have any questions, please let me know. Um, and I'll be happy to help. I'm really sorry for all the bugs, but I guess, I mean, yeah, it happens with everyone, honestly. Like, we all, you're not actually coding if you don't have any bugs in your code, then you're just copying the code. But if you have bugs, this means you're actually doing something. um, and yeah, buggy code is actually good code because debugging is what teaches you. How I was able to figure it out was because it was printing the get signer thing after, you know. So I was able to figure out, okay, it's not waiting for it to get the the address. So yep, that is it. I'll wait for 5 minutes. I'm so sorry for the long tutorial. I hope you guys understand what's going on and the flow of things. Um, uh, Go ahead and also try the claim thing. Um, and yeah, um, we just did the main thing, but you guys should also do other stuff. I'll play around with this and try to add new things to this, anything that you essentially like. Please suggest DeFi projects like 2, 3 projects which are trending. I did Dex already. Um, what kind of DeFi projects are trending? I mean, DeFi is very related to finance. I think we'll do a little bit of uh, DeFi in the sense that in the senior track we learn about flash loans. So that's very trending in DeFi right now. Um, and we'll teach that in senior track how to do flash loans and everything. And how what else like you do in DeFi? DeFi you can do synthetic assets. DeFi, I think you can also do, futures trading. These are concepts that are really, really, you know, complicated to make. You can also make a DEX aggregator, something very similar to one inch exchange. So they aggregate the prices from multiple DEXs like Uniswap, SushiSwap, and they aggregate it and they let you know of like the best prices you can get. I guess I can open it up one inch exchange. Um, this is actually a really cool uh, DeFi project. I'm not sure why I can't open this exchange. Oh my god, is my internet again down? Okay, yeah. So this is the one inch exchange aggregator. This is their swap, and they essentially tell you, the different taxes. So, like for example, Uniswap is charging you this much, and one inch is charging you this much. So they give you the best value that you can get out of the thing. So it's like an aggregator. Um, and yeah, that might be a pretty cool project to build if you really want to. Um, yeah, you can also learn about Aave, which is like lending and borrowing protocols. I think there's so much in DeFi. We'll talk about this more in the future. We'll do some stuff so that we can explain it in detail. I know like DeFi is one of the most talked about topics, but it's such a vast field that you can't talk about it in 5 minutes, I guess. It requires much more in-depth explanation of things. Um, DeFi staking in dApp, is that good? Yeah, DeFi staking dApp is actually a good idea. Staking is one thing is which is like really really common these days. Even NFT projects are trying to do staking. Looks rare, it's staking. Yeah, that might be a good idea to do for sure. It seems tough after completing freshman track. Um, it it's not. I think if you keep doing it, like obviously the first time you do it, it's going to be hard. The whitelist app, there's so many things that get introduced, but once you keep doing it, there are a lot of things that are going to get repeated. And when you keep doing it and when you keep doing it, that pattern you understand and things become much more clear to understand. Um, so I just would say like don't give up. Don't feel demotivated. If you have any questions, ask them on develop. Don't fear it, okay? Um, don't fear learning. We all start from somewhere, right? Like for example, I don't know a lot of things. For example, I don't know ice skating. So I'm probably gonna fall many times, right? And I'm gonna keep falling and I'm gonna keep falling until one day I can actually like ice skate properly. So, but if you fall, there are other people who don't like people don't like laugh at you or anything. People actually appreciate your efforts and they try to help you and teach you how to actually ice skate. It's very similar to that, right? You keep falling, but you get up and you try again and you try again until you are actually able to do it. Um, so don't be afraid to not knowing things. Be afraid to not trying things out. Um, Ask for help, go out, don't feel like you're asking stupid questions. There's nothing like stupid questions according to me, because even I make mistakes, even I blabber things. We all make mistakes, right? And it's okay because we are humans and we are ought to make mistakes. Don't feel scared, I would say. Just go ahead and do it. and you'll feel proud that you did it, right? Um, you always feel um, happier when you do things you think are tough. You never feel happy doing easy things. You always feel happy after you've done something which was hard and you're proud of yourself, right? For doing something which was something you thought you can't do, and then you end up doing it. That's how you grow. That's how you, like, I guess, learn. Um, so yeah, um, don't feel like you can do it. Just do it. Learn a little bit of React. Learn, things that are going on here. Let me know if you have any other questions. Okay, I guess I'm gonna end the stream, or should I wait? Let me wait for 3 minutes. Until then, let's look at some cool stuff. Okay, so Aave is something I was talking about. So let me open this up. So you can earn interest and borrow assets and build applications, right? So you essentially can, it's like a bank essentially. So you can, you know, add some extra ETH that you might have and you can earn interest on that. You can also borrow some assets against some assets. Essentially like how banks work. So this is actually a pretty cool thing. Um, then one inch exchange, I already showed it to you. There's Curve Finance. Um, it's essentially something, but this is mostly optimized for stable coins. So how we taught you Uniswap, and Uniswap was essentially for like coins which have a varying it's optimized for coins with varying liquidity. This one is optimized for stable coins. So it's kind of like similar to Uniswap, like where you can do this with swap this for USDT or something, and it is optimized for stable coins, and it has a different formula which is x plus y is equal to k. Um, I guess you guys haven't done um, DeFi yet, but there are many, like, if when you reach to the DeFi tutorial, you'll learn about some formula called as xy is equal to k. Yeah, so this is for stable coins like USDT, USDC, um, DAI. So yeah, these are some of the DeFi stuff. Okay, I'm gonna go ahead and end this stream. Thank thanks all thanks for joining, and I'm sorry for all the inconveniences, and I'll see you in the next one. Have a good day, good night, and take care, and give your best.